The material on this slide is the heart and the soul of this entire course. But it's also really complicated, so don't expect that it's all going to make sense the first time through. But we are going to be talking about it again and again and again, and hopefully by the end of the course this will be second nature. The idea of psychopathology and the specific disorders that we diagnose of psychopathology represent constructs. A construct is an idea. It doesn't have a reality. It's an idea of what we think is there. The idea is constructed by the researcher, and then we look to see if the evidence supports that idea. Now, in order for us to study an idea like schizophrenia, a particular diagnosis, we have to have a way of measuring schizophrenia. And we do that by having a set of diagnostic criteria so that I, as a psychologist, can interview a patient and say, yes, they have schizophrenia. And if it's a good diagnostic criteria, another well-trained individual can interview the same patient and come to the same conclusion. What we want to do once we have established a construct like a diagnosis is we want to see if that construct is accurate. We call that construct validation, one of the most complicated concepts there is in all of science. In fact, all of science is based on construct validation. Now, we don't have time to cover everything in construct validation, but basically when we're studying a particular disorder, we want to know, is that disorder real? Are the people with that disorder similar to one another, but different from other people who don't have the disorder or who have some other, perhaps similar disorder? Do they show a similar course over time? People with schizophrenia, for example, tend to have symptoms that last most of their life, although the severity may come and go. People with major depression tend to be very depressed, but much of the time they're not depressed. They have episodes that come and go with depression. That's called the course for the disorder. Are there treatments that reliably work for individuals with that diagnosis? Answers to those questions tell us whether that diagnosis is reasonable, whether it is valid. And that's what we're going to be talking about throughout this course. Now, I want to remind you something I said earlier in this particular lecture. Most of what I was taught and most of what I taught students when I first started teaching this course, we no longer consider to be true. That is, the process of construct validation has changed the diagnostics, changed the particular diagnoses that we accept, sometimes adding new diagnoses, sometimes combining diagnoses through a process of scientific research so that the current situation is far more accurate than our expectations, our ideas of 40 or 50 years ago. There's a corollary to that, which you probably are thinking about right now. What I'm teaching you right now is probably going to, in 20 years, no longer be considered accurate. The research will give us a better understanding, and the ideas that we have that turn out not to have been very good will be replaced by better ideas. Every field based on science is constantly evolving, and you need to remember that. Let me formally talk about the concept of reliability, which is so important in research. There are three types of reliability. One is across observers. If you and I talk to the same person, will we have the same impressions? Will we come to the same decision about what, if any, diagnosis they qualify for. That's called inner rater or inner observer reliability. But we also look at stability over time with test-retest reliability. Now, not all concepts that we will measure are going to have test-retest reliability. Anxiety, for example, tends to come and go. So if I test your anxiety today and in a week, very likely the numbers are going to be different. It isn't that our measure is bad, it's that the thing we're measuring is simply not stable. We can also look across many different situations and see if we continue to get the same results. We call that internal consistency reliability. For example, people who tend to be anxious, are they anxious here and here and here and here in all of those situations, or are they anxious in only certain situations? By the way, internal consistency reliability is not characteristic of all psychological symptoms, but it is characteristic of some psychological symptoms. So the type of reliability depends on our concept, our construct. We expect anxiety to come and go, so we don't expect test-retest reliability. We expect intelligence to be stable, so we expect it to have good test-retest reliability. In our field, the one thing that we absolutely have to have is inner rater reliability. If we can't agree on what a person has, we can't study that diagnosis, because we can't find a group where everyone says, yes, they all have that diagnosis. Remember, that is why DSM-1 and DSM-2 were, for all practical purposes, useless, because we couldn't get inner rater reliability. Now, the concept of validity is often confused with reliability. Reliability is consistency. Validity is accuracy. So when I'm looking at concepts of validity, I'm talking about whether or not they predict what they're supposed to predict. And it's important when we are defining validity to name what it is that we're expecting. Let me give you an example that probably will be easy for you to follow. You all have a sense of what intelligence is, although you may not have a sense of what factors contribute to it. And you know that people who are intelligent tend to behave in certain ways that are different from people who are not intelligent. They tend to learn more easily, which means they tend to do better in school. They tend to get higher grades. And because they do well in school, they may stay in school longer and get more education, perhaps a better job as a result. And because they've got a good job, they may feel good about themselves and they can be happy. Now, those are separate predictions from the idea of intelligence. It turns out that intelligence measured with an IQ test is an exceedingly good predictor of performance in school. Now, it's not a perfect predictor. Some people do well in school because they work harder than other people. They may be intelligent, but any lack of intelligence they overcome with extra work. And there are people that are very intelligent and don't work very hard, and so their performance is less than it might be. It turns out that intelligence is a less valid, although still valid, indicator of how far you go in school. Why is that? Well, if you're doing poorly in school, you might drop out, but a lot of people who are doing fine in school drop out for a lot of perfectly reasonable reasons. They may not have enough money to go on to college, for example, or things may happen in their life that require them to take a different course. So there are other factors that affect how far people go, and therefore the predictive validity, the relationship of intelligence to how far you go in school, is not as strong as a relationship of intelligence to performance in a given class. What about intelligence and happiness? I don't think many of you would be terribly surprised to find out that although one could make an argument that intelligence helps you to get a better job, which helps you to have more money and helps you to be happier, etc., turns out there's almost no relationship between intelligence and happiness. There are many people very intelligent who aren't very happy. And there are some people who are very intelligent who are extremely happy. But there are people with average intelligence at both of those extremes and lower intelligence as well. So there's not much relationship. There's not much validity to intelligence as a measure of happiness. What that means is, if anyone tells you that intelligence is, or IQ tests are valid, don't believe them, because they clearly don't understand validity. If they understood validity, they would say intelligence tests are a valid predictor of performance in school. If you don't say what they're valid for, it makes no sense. Or they're a valid, modestly valid predictor of how far people go in school. But they're not a valid predictor of how tall someone is, or how happy someone is, etc. So with validity, you have to specify what it is that you're trying to predict. Most of you have probably heard of correlation or correlational research. A correlation coefficient is simply a statistic, easily computed, that gives you an indication of the strength and the direction of a relationship of two or more variables. I'm going to focus here only on two variables, but there are correlational techniques that can be used with more than two variables. Typically, a correlation goes from a -1 to a +1. A +1 means you have a perfect positive relationship. As one variable increases, the other increases at precisely a determined rate. So I can tell you exactly what the other variable will be if I know what the first variable is. A minus correlation is also a perfect relationship, but in the opposite direction. As one variable goes up, the other goes down in a perfectly predictable manner. A zero correlation means that there is no relationship. Now, in general, the correlation coefficients we use only measure accurately what we call linear relationships. That is a tendency to create a straight line where most of the points gather around that straight line. That'll make sense in just a minute. And we use correlations to do predictions. What you see in front of you is a scatter plot. A scatter plot is a series of points that are determined by two scores for each of the subjects in your study. So for example, down in the bottom, Isadora has a dot here, which represents her score on the x-axis of her recent life stress, and on the y-axis of her level of depression. Each point represents a person who has two different scores. In this case, we have a very strong, much stronger than we typically see in psychology, positive correlation. As recent life stress increases, the level of depression increases. Here we see a very strong negative correlation. Instead of life stress, we're looking at activity level, but we're having depression on the y-axis again. So as the level of depression increases, the level of activity decreases. This is a zero correlation. In the scatter plot, the dots are completely random all over the place. The horizontal line there and the lines that you saw in the previous scatter plots are the regression lines that can be used to predict things. When there's no relationship between the variables, the horizontal line will typically be at the mean score for the y variable, in this case depression. So if I don't know anything about, for example, a person's intelligence, or if I do, it wouldn't matter if I'm supposed to predict their level of depression, my best prediction is going to be the average depression for people in general. Now, this is the same scatter plot that we saw earlier, looking at life stress and depression. And in fact, there is a modest relationship between life stress. Now, modest means that these points are not closely aligned with this prediction line, but tend to cluster around them. Occasionally closely, but sometimes not so close. This is very close to the actual regression line that we would find, scatter plot we would find, from a very well done study looking at life stress and depression. Now, there are two things that I want you to remember about correlational research. First of all, if the relationship is not linear, you want to be very careful about using correlations because they can be very deceptive. And many things in psychology are not linear. Let's take, for example, the level of arousal and performance. Now, arousal at higher levels can be very uncomfortable. We call it anxiety. So, if you are so relaxed and it's time for an exam that you just kind of take a deep breath and fall asleep, you're not going to do well on that exam. If you are a little anxious, you're probably going to do fine. And if you're a little more anxious, you're probably going to actually do a little better. But probably most of you have had the experience of being so anxious that you can't even remember your own name, much less the answer to the questions on the exam. Walk out of the exam and suddenly you calm down and you can remember all the answers, but it's too late. The exam is over. So your level of anxiety improves your performance up to a point, and then it dramatically drops your performance. That's a nonlinear relationship, and a correlation does not do a good job of summarizing that. But the second point is even more important. I want you to be so familiar with this point that if you were in a coma, you would be repeating it over and over like a mantra. Correlation does not imply causality. A relationship has to be there if there is a causal connection. But the fact that it is there does not mean that there is a causal connection. Because if A and B are correlated, it might be that A causes B. Or it might be that B causes A. Or it might be that there's some third variable. Might be hundreds of third variables that cause both A and B to occur. And yet it's so tempting when we see A and B correlated with one another. It just seems obvious that one is causing the other. Well, it's not obvious. And in most of the cases, our interpretation of that is wrong. Now, let me give you an example that you may find a bit surprising. Do you know that the murder rate and the rate of ice cream consumption has a moderate correlation with one another? Think about that. The murder rate and ice cream consumption. Okay, what does that mean? Do people who murder other people suddenly want ice cream? Does murder cause an increase in ice cream consumption? Or do people who eat ice cream want to go out and murder people? Maybe they got an ice cream headache as a result of it. Ice cream consumption causing murder. More likely, there's some third variable, and you probably guess what it is. In this case, murders are more common in hot weather, and ice cream consumption is more common in hot weather. So the temperature may be a variable that's contributing to both. Again, correlation does not imply causality.